Suppose you are given on a test, you decided to prove this. So just hang on the video, just show you how to prove the statement of on the screen. You're just going to take an approach that Carl Friedrich Gauss did take when he was on his foundation phase, when the teacher said you should just try to add numbers from 1, all the numbers from 1 up to 100. So the teacher thought this thing would take so long, but not for him. So he's just going to use his approach on how he solved the problem. Exactly this is what he did. He just listed numbers they need to add. It was like 1, 2, 3. Onwards and onwards, and had like 97, 98, and 100. And then after writing them down, he noticed some relationship. He noticed that whenever I add this term and this one, he gets 101. The same thing happens when you add this, and you also get 101. And if you add this, and again you get 101. So he noticed that this is just a repetition of one thing. So if you keep on going through that till you find you on the center of the whole thing, that means you have added 50 terms. Then you'll have 50 101s. That is going to be a sum that we called God. So then if you work your maths, your sum is going to be 50 50 if you did your computation very well. So teacher thought this could take so long, but it didn't for him. So we're just going to just go deep in how he got to this solution, which is the correct answer. If you have enough time, you could just pause the video, add all you want, 2, 3, 4, 5 to up to 100. So obviously we'll get 5050 as much as we get. So if we just try to analyze what we just wrote here. Here we're supposed to add 100 from 1 up to 100. We could notice that whenever we add this number and this one, we get 100 plus 1, of which is just simply the number of terms that we're supposed to add plus 1. This is it. 100 plus 1, of which is n plus 1. But we had to times it by the number of terms that we're taking was 100, right? And we have to times this is 50 exactly. It's more of like it is how much we're supposed to add. It's how much we're supposed to add 100 terms, right? And we times by 50. It's like half of it. So it is simple as number of terms divided by 2. And exactly, if you just look carefully, this thing is really the same as this one. So we're just going to do more maths since it makes sense to you. Simply, this is just the number of terms that you're supposed to add plus 1 times half of the number of terms you're supposed to add. It's simple as this. That's how the guy did it. We'll also try to do it in the most mathematic way. So exactly what he did is said the sum should equal to 1 plus 2 plus 3 on and on and on, and 97. Let me do it this way. Until you go on till you go to the number of terms you're supposed to add, and the number below it is going to be the number that you're supposed to add minus 1, and below it's going to be n minus 2, onward and onwards. Okay, so this is a sum of nth term. Okay, so we're just going to flip this thing. Start it from here. This is the sum. Okay, so should have pluses. So we're going to flip this thing, write it the other way around. So if we do that, we're going to have n plus, this is the n, this is plus, if I'm not mistaken, n plus 1 going this way. Then we're going to have n plus 2. Wow. Okay, I made a mistake. There's supposed to be minus all this long. Okay, let me fix that. Okay. Yes, and up to we have, we'll also add n minus 3. So until we go this side, we had 3, we had 2 up to 1. So we're just adding some of this and also some of this, but we're adding them vertically like this. So exactly what is happening, if we add this and this, obviously we're going to get n plus 1, and again if we add 2 and this, we're going to get this 2 minus going to be n plus 1. Remember there's a plus here, also should have used bracket here. And if we added this one and this one, again is going to be plus n plus 1. If you could notice, you could just do this thing forever. It's going to be another n plus 1, and keep doing it. You get n plus 1 until you add all of them. And if you, this is going to be Sn plus Sn, of which gives you, it should give you 2 sums. 2 sums equals to what? The n, these things are n. Yes, they are n, like nth n plus 1, and that is going to be your n plus 1. Okay, these things are n, you're just going to have them till they are nth times. So remember, we're looking for the sum, not the double sum. Then we divide by both sides by 2, both sides by 2. Then the sum is going to equal to n open bracket n plus 1 all over 2, of which, and again, it's look exactly like this one. So we just prove it. Just for the last time, we'll try to look at this thing in the most graphical way. Let me say I'm trying to add terms like from 1 up to 5. We're also on a proof, we're still on a proof, which is going to be 1 plus 2 plus 3 plus 4 plus 5. I don't know the answer, obviously, sum of 5 terms. But there is an answer. You could just use this formula just prove, but we're still trying to prove it again. So exactly, if we try to draw that graphically, we're going to have 1, 2, 3, 4, 5. This is it. And we're adding to 4. 1, 2, 3, 4. Adding 3. 1, 2, 3. We're adding 2. 1, 2. We're adding 1, 1. This thing is a triangle. We can't really work with things in a triangle very nice. They're always complicated. Let's try to fill it up, make it a square. So let's try to make it a square. Okay, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Okay, so we can notice that this side is 1, 1, 2, 3, 4, 5. It's like nth, the number of times we're supposed to add. And if we go here, obviously it's a square, it's another n. So here we're going to have n squared, n and n. So from now we can really say this, let me use a different, this here is the sum that we wanted. So that is the sum that we wanted. And here there's another portion, the green part that I just added. It is also a sum. Yes, it is also a sum, but this sum is missing something because this started 5, this one started 4. It's missing the 5 row. The 5 row is the nth row. And then it is missing n. You understand? This is the sum that we wanted, and we've added something that is sum less, nth less than a sum. So what do we have now? So now we have 2 sum minus n. If I'm saying 2 sum minus n, this is what I'm referring, the box without those stars, because stars are not there, the box. And the box, we know what is a box. A box, I just said, it's n squared, which is equal to n squared. Then you can do your math from here. It's going to be n squared plus n is equal to 2 sums, because I want one sum, divide by 2, then I have sum equals to this. But here you can do something. There's a common factor. I take it out, it's n open bracket, where I'm left with n plus 1 whole over 2. This is also equals to this. So graphically, this is how you should picture it, how we made it up. So exactly, I repeat again, or you can just rewind the video. This is the sum that we wanted, and this is nth less than a sum. Then we add those two, they give us a cube. A cube is nth squared, which we just represented that, and solve for a sum, giving us the very same thing as the one that we wanted to prove.